Digital isolation is crucial for ensuring the safety of electronic systems, as it protects sensitive microcontroller units from potentially damaging high-voltage signals, noise, or other hazards, and allows digital signals to pass through. Basic isolation provides sufficient insulation material to protect a person or device from electrical harm. However, the risk of electrical malfunctions is still present if the isolation barrier is broken. Some applications use a second layer of basic isolation in case the first one goes down. Reinforced isolation is equivalent to dual basic isolation, and is implemented by strengthening the isolation barrier to decrease the chances of the barrier breaking compared to basic isolation. Isolation can be implemented in 3 different ways. The first implementation method is optical isolation. It is implemented using optocouplers to transmit data through a light signal. To perform the transmission, the light-emitting device and phototransistor are used to transfer data across the isolation barrier. In other words, data is delivered between the two sides via light rather than between electrical connections. This eliminates the problems of noise, voltage spikes, and other risks. However, the main challenge with optocouplers is that they have a short lifespan. The second method is inductive isolation, where energy is transmitted from one side to another via magnetic fields. This is sometimes also called magnetic isolation. Inductive isolation uses a transformer to transmit electric signals and power. The separation between the two coils prevents direct current flow and provides isolation between the input and output circuits. In order to transfer power from the transformer's primary side to its secondary side, that power must be converted into an AC signal. The AC signal generates the magnetic field, which crosses the isolation barrier. At the output, the signal can be rectified to have a DC output. The final method is capacitive isolation, which uses capacitive coupling to safely transfer information through the isolation barrier. Capacitive isolation offers the best performance regarding the isolation voltage, high reliability, and compact form factor. Capacitive isolation is primarily used to transfer data at high rates. To transmit data through the isolation barrier, capacitive digital isolators require additional circuits such as a modulator to increase the frequency of the control signal and a demodulator to convert the signal into its original form. Magnetic isolation is usually preferred for power transmission, whereas capacitive isolation is used for data transmission. MPS provides a combination of isolated power and isolated data transmission within a single compact package. The MPQ278xx family of digital isolators with integrated power uses capacitive isolation technology to support an isolation voltage rating up to 3 kV. This isolator provides small size, low power consumption, and higher reliability operation compared to traditional optocoupler isolators. The MPQ278xx family also integrates one isolated DC to DC converter with up to 200 mA of output current and 3 kV of isolation, providing isolated power for the isolated data port. The MPQ278xx family of digital isolators with integrated power comes with several output options, from 2 to 4 channels. This family supports data rates up to 50 megabits per second and a 3.3 volt to 5 volt input voltage range. The MPQ278xx family of digital isolators with integrated power leverages advanced isolation techniques to enable a wide range of applications, such as EV charging stations, battery management systems, industrial communication systems, industrial automation systems, and programmable logic controllers. To learn more, visit monolithicpower.com. Like this video and subscribe to our channel to get the latest on our innovative new products.